concept of the Newton's law. Yeah. When the object has constant speed or object is in rest, yeah, the total speed equals to zero. Ini ada dua condition, dia rest ya, or dia adalah constant speed. Ya. Total force equals to zero. So when the car has driving force, this is driving force. Ya. Driving, and this is resisting force. Ya. So when they goes on the constant speed, yeah, driving force minus resisting force equals to zero. So we can say driving force equals to R, yeah, or R equals to driving force, yeah, 870 Newton. And how about the acceleration when they come to driving force 1,200 Newton? So we will use the formula of Newton's second law. The Newton's second law, if the car or object has acceleration, yeah, constant the acceleration, total force equals to ma. Then driving force minus resisting force equals to ma. Driving force, the second driving force is 1,200 minus driving force, the first driving force, yeah, as the 870 Newton. So equals to mass of the car 1000, yeah, times E. So this is 330 equals to 100A. So A equals to 330 divided by 1000 equals to 0.33 meter second minus 2. Yes, that's the question for A. Now, but question B is, yeah, find the resistance of the motion and the acceleration when the car is moving 20. Okay, B, yeah, when the car has velocity like V2, yeah, this is V2 is 20 meter second minus 1. So find the resistance and resistance to motion and the acceleration. Yeah. Wait. We have about two condition of velocity. When velocity, the first velocity is 15 meter second, the second velocity is 20 meter second. This is actually about ratio between force and force. Yeah, uh, we have 870, yeah, Newton. Sorry. I use the formula of F1 divided V1 equals to F2 divided by V2. 870 Newton divided by 15 equals to F2 divided by 20. So F2 has number 1160. We have F2 as the 1160 Newton. Yeah. Yeah, actually, this is about the resisting force. Yeah, actually, this is resisting force. Yeah, so we can say F2 as the resisting force of 2. Yeah, this is 1160 Newton. Because the question is find the resistance of the motion, and then the second one is the acceleration of the car moving. Yeah. This is the resisting force when they have velocity 20 Newton. This is the new formula, yeah, with ratio between force and velocity. Yeah. So, what about the acceleration is? The acceleration we use the formula of driving force minus 2 equals to resisting 2 equals to ma. Yeah. This is actually m2. Sorry, a2. Yeah. This is still 100, 1200 minus resisting force is 1160 equals to 1. I don't know. Yeah. So, mm, 40 minus, yes, 0.04. Yeah. 0.04 meter second minus 2. Yes, this is the answer. Yeah. This is the formula of Newton's second law. Yeah. But in different resisting force. Yeah. Eh, kok bisa? Okay, after this we will go to free fall. Yeah. Yes. About free fall. Yeah. Or vertical motion. Like the object has velocity u and then like This is, yeah, let's say V, and then they have 8 as the 8. Yeah. So the formula is same with the motion in straight line. Yeah, we have V equals to U plus AT plus, but A we change into G, yeah, times T. Then we have distance as the height, yeah. This is also ut plus a half, and then the acceleration is g t squared. And the last one is v squared equals to u squared plus 2g h. Yeah. So actually we change about the acceleration, yeah, change into g, and height and distance change into height. Yeah. Yeah, you can open the file on the Google Classroom on the stream. Yeah, on the stream, I put one file again about free fall. Yeah, about free fall or vertical motion. Yeah. They have when they goes on the up. Yeah, they have the deceleration minus g, and then we go down is positive g. Yeah, this is about decelerate, and this is about accelerate. Yeah. And when they hit the ground, so the velocity is same back to u, yeah, but in different direction, yeah, different direction. And at the maximum point, yeah, at the maximum point, the velocity is come to zero, yeah, because decelerate by gravitational deceleration. Yeah. I will open the file, yeah. Sorry, apa? Okay, I have one question. Yeah, when someone, somebody has throw a ball, you strike upward at a speed 5 meter per second. Here is 5 meter per second, and they have on the building that the building is 100 meter, yeah, tall. When the ball returns to you, yeah, you should not catch and let the ball continue falling the ground without hitting anything. Yeah. How long will takes? Yeah. How long will take for the ball to reach the highest point? Yeah. Wait. I will move go to right. Yeah. Yes. The question one is, yeah, time until highest point, yeah. Uh, Time until highest point. How long will it take for the ball to reach the highest point? Yeah. Let's say T, yeah. Say T1. Okay. On the highest point, yeah, velocity is zero. So if we use the formula V equals to U plus GT, yeah, yeah. Let's say we use G as the 10, yeah. G is 10 meter second minus 2. So here is 0, yeah. U is 5 plus, but then this is negative, yeah, because decelerate, yeah. When they goes up is decelerate, when it goes down is accelerate, yeah, and times t. So we can say this is 10 sorry, plus 10. 10 t equals to 5. So t equals to a half second. And then B, yeah, continue to B. Yeah. I open again about question. How long will it take for the ball to hit the ground? A. Let's say T2. Yeah. Okay. I think that yeah, when they go until here, yeah, uh, the velocity is same. Yeah, this is back to 5 meter per second. Yeah, but in different direction. Yeah. So we but we'll use the formula. Yeah, we have. Oh, but if we use the formula as the h, yeah, equals to ut plus a half gt squared, 105t a half 10 t squared. Okay, 105t 5t squared. Oh, actually we use the formula of mathematics. When t equals to t plus t squared, yeah, or t squared plus t minus 20 equals to 0. Mm. How much is it? This is 5 minus 4. Or we get t equals to minus 5 or t equals to 4 second. Yeah, we used to use this. Yeah. And then after we know about T, the T is yeah, the T is when the ball is on the height 100 meter until hits the ground, not as the T2. T2 is when the ball is in highest point until the ground. So we can say T2, yeah, T2 as the T1 plus 4, yeah, or T1, yeah, this is T1, is 0.5 and then plus 4. This is 4.5 second. Yes. This is time when the ball, yeah, from the highest point until hits the ground. Okay, I will continue again about C question. Yeah, C question is highest point until the ground. Yeah, how high in the highest point relative to the ground. Yeah, how high is, yeah, on the maximum point until the ground. How high is, yeah. Uh, Actually, we already have about the building height is 100 meter. Yeah. So we need to find the highest on the maximum point until the top of the building. Yeah. So let's say it's a high. Yeah, high here. Yeah. This is high as the small h here. Yeah. We use formula ut plus a half gt squared, or if we use from this point, the main point here until the highest point, so we can say here is 5. Yeah, t, we have t is t1 0.5 here, 0.5 plus a half of g is minus 10. Yeah, because goes up. Yeah, and then t is 0.5 square. So this is 2.5 minus uh, 0. Wait, 1.25. Yeah, this is 1.25. So we can say this is 1.25 meter. Yeah. So total highest point. Yeah, here h as the 100 plus 1.25. Yeah, so this is 101.25 meter. Yeah. This is total height here from the highest position. Yeah, from the highest position until the ground. If you have any question, just let me know ya guys. Kalau ada yang mau ditanyakan, bilang saja.
Pak.
Yes. What?
Boleh nanya nggak, Pak?
Oh, nanya boleh.
Yang tentang force and acceleration yang kemarin.
Iya.
Aku kurang ngerti 4C.
4C. Oke, coba serbuka dulu. 4C.
Oke.
Oh, 4C. Force. Yang pertama kali ya. Wait. Velocity and acceleration. Oh, graph ya, grafik ya. Wait.
Pak, sebelum grafik. Halo.
Yep. Oh, sebelum grafik yang C ya. Yang ini kan hover short the barrier does come to stop. Sebentar, ingat-ingat dulu hover short. Oh, ini kan setelah itu kalau nggak salah kita dapat 45 meter, ya kan? Kira-kira berapa meter lagi sementara ini ada 50 meter? Ngerti nggak, Gebi? Itu kalau kita masukkan nih 900 nih. Ini formula V adalah root of gitu 900 minus 20s ya. Gitu. Nah, kalau kita sampai dengan dia stop ya, they have V is 0, so 0 equals to or 0 equals to or 2s equals to gitu. S equals to divided by 20, this is 45 meter gitu. Nah, total jarak ini adalah 50 meter. Sementara dia ini adalah nyampenya 45 meter. Berarti sisanya ini gitu. Ya. Delta S-nya itu adalah 50 minus 45 equals to 5 meter gitu. Ya. How far short of the barriers does she come to stop?
Thank you, Pak.
Yep, okay. Oke, sebenarnya itu. Oh tadi di screen ya nggak kelihatan. Nah ini ya kelihatan nggak? Oke, selesaikan satu option lagi yang ini ya. Nah, what the final speed before the ball hits the ground? Ya, velocity di sini berapa nih? Ya, velocity here berapa kira-kira? V ya. Final velocity when the ball hits the ground. Ya. Uh, I use here aja deh. Ya, ini aja. Ini 100 meter. We use formula V square U square plus 2GH. Ya. V square equals to U square as the 5 ya, square plus 2G as the 10 and then positive ya, and H is 100. So this is equal 25 plus 2, yes, 2000 ya. So V equals to root of 25 ya. Ya. Akar dari 2025. Root of 2 to 5 is 45. Ya. This is 45 meter second minus 1. This is the D1. Ya. So the velocity until hits the ground is 45 meter second.